All right, so the last piece of 2.8 in terms of stuff we need to know. So just to recap, we understand how the line is made by minimizing those squared residuals. We understand how to use those formulas that are given to you on the formula sheet to calculate the regression line or maybe answer a more conceptual question. And last, we might need to interpret both the slope and the y-intercept of that line. So these are the interpretations that you might use as a base in terms of memorizing. So for slope, just to remind us, slope is change in y over change in x. So say you're in this next example where we have a slope of 0.764. We could put that over an invisible 1, right? So our change in x is going to be 1, while our change in y is going to be 0.764, which is basically what we're writing out in this sentence. The only other piece besides as our x changes 1, our y will change the slope amount, is that we want to have the word predicted or on average or expected, something in there to say that this is not a guaranteed thing. We don't want it to be too deterministic is the wording that they use when you do this. So you want to make sure it's something about how the line predicts this or we expect this, as opposed to just saying every time you do something, here's what's going to happen. And then your y-intercept, just like in a regular equation or y-intercept or regular line, right? Our y-intercept is where we cross the y-axis. So this is what happens when our x is equal to 0. That's the exact same interpretation you're going to see here with the the y-intercept. If the x is 0, you would predict the y to be y value. All right, so let's go ahead and interpret both of these for that previous example we had with systolic blood pressure versus weight. So previously, we could look back, we used weight to predict systolic blood pressure. So that's our x variable and our y variable. So we're just going to go ahead and run out these interpretations. So the slope, as we noted, is that 0.764. We would say for, I like every more than each, it doesn't really matter. For every 1, and then our units of x, we just want to make sure that we're being kind of consistent here. Weight in that particular example is 1 pound. Increase in weight. And obviously there are other ways to say this. You could just say every pound gained, or every time your weight increases by 1. You don't have to use this exact setup, but it needs to be something about change in x being 1. So for every 1 pound increase in weight, our y variable, which is systolic blood pressure, is predicted to, and since it's a positive slope, we're going to say increase by 0.764, and then our units for systolic blood pressure were millimeters mercury. So there's our slope interpretation. And our y-intercept, this would be for and this would be our x again, so weight of 0 pounds. We would predict, oops, that's fine, predict systolic blood pressure to be, and that was 1.1. So again, all I've done in each of these problems is sort of, if I memorize these sentences, just went ahead and input stuff, right? So my units, the x variable itself, the units of that x variable, the y variable itself, the units of the y variable, and the same deal here, right? X and the x units, and then y and the y units along with my y-intercept. So there you go, that slope and y-intercept. As we discussed in the previous example where we were doing the radius, length, and height, y-intercepts do not always make sense. So in this case, they definitely don't. Like, there's no such thing as someone weighing 0 pounds. So that intercept interpretation is nonsensical. So that's it for exercise 2. I'll throw exercise 3 into the next video.